So as I was talking, question number 4, A inverse equal to adjoint of A by determinant of A, where adjoint is cofactor then transpose. So for cofactor, A matrix is given. So for every position you have to find cofactor 1 1 1 2 1 3 2 1 2 2 2 3, and then 3 1 3 2 3 3 1. This portion I am showing details. This one you can calculate. So for 1 1 you can remove this first row and first column. Then you see these are there. So if you take, and it is always plus minus plus, then again minus plus minus, then again plus minus plus. So plus 1 into 1 minus 0 into 1. For 1 2 you will remove these and these. So it will be 1 1 0 1 1 1 0 1. It is minus, because plus minus plus, then minus plus minus, then plus minus plus. So if you similarly you can calculate for 1 3. All other things you can calculate. You can calculate determinant also. So you put all these value in the cofactors 1 1 1 2 1 3. Then you take transpose of that one. That will become adjoint. So if you divide it by what is your determinant? Determinant is 2. You can calculate determinant. You expand with any row, 1 into this into this into this, then the plus this into this into this, then plus this into this into this. So you can calculate, I think. So the answer is this one. So very easy one. So if you forgot inverse, so just refresh it. Question number 5. Then what is question number 5? To find the eigenvalues. Eigenvalues yesterday also in last lecture we have already seen. What is eigenvalue? How the eigenvalue is calculated? It is A minus lambda I. So next I will not take any eigenvalue questions. If it is directly eigenvalue, I will showing it for last time. So take it is A minus lambda I. So basically what is happening, from the diagonal you will minus lambda. That's okay. That's all. So this is 0. So 0 minus lambda 1 0. Then 0 0 minus lambda 1. Then it is minus 6 minus 11 minus 6 minus lambda. So determinant of that one is equal to 0. I think you can calculate determinant. So this into this, minus 1 into minus 11, then plus 1 into 0 into minus 6 minus lambda minus 1 into, I am showing in details. So if you solve it, you will find an expression of lambda which is somehow equal to lambda cube plus 6 lambda square plus 11 lambda plus 6 equal to 0. Now a cubic expression. Suppose if it is been a quadratic also, it is easy, you can solve. Cubic also you can find, factorize it. But if there is option, you check with the options. Suppose the option is lambda equal to 1 is option. So you put the value lambda equal to 1. If the equation satisfied, then this is your answer. Check with other options also. There may be multiple correct options, or in an option there may be 2 3 1 comma 2 or 3, something like that. So you can check. So if it is not there in the option, then also you have to factorize it by just checking it with this one, because calculator is not allowed, scientific calculator. So you can put lambda equal to minus 1. So if you put minus 1 here, you can put 1. If I put lambda equal to 1, then it is not 0. This side is not 0. 6 1 plus 6 plus 11 plus 6. So it is not 0. If it is 0, then we can proceed. So we will check next lambda equal to minus 1. If it is not, then lambda equal to 2 minus 2. 1 2 3 you will get it answer. So if it is minus 1, so it is minus 1 plus 6 minus 11 plus 6. How much it is? 0. So it is satisfying. So lambda equal to minus 1 means lambda plus 1. If you take minus 1 this side, so lambda plus 1. So this become a factor of this one. So you can factorize it. You can divide this one by lambda plus 1 to get the remainders, or you can factorize it by using this lambda plus 1, lambda plus 1. Because it is cube, you write it 3 times. I think you have done in your old school level classes. So for make it a cube, you have to put lambda square. Now how many it is now? Lambda cube it is. 1 lambda cube, okay. How much lambda square? 1 lambda square. How much lambda square you need? 6 lambda square. So you have to put 5 lambda here. So 5 lambda will be 5 lambda square plus lambda square, 6 lambda square. It is done now. How much lambda it is? 5 lambda, but it is just 11 lambda. So you need 6 more lambda. So it is 6 lambda plus 6 equal to 0. So you can take lambda plus 1 common from here. So it will be lambda square plus 5 lambda plus 6. I think you can now factorize it. So you will find the answer lambda equal to minus 1, minus 2, minus 3. So these are the eigenvalues of this one. So in any of the equations, if you, not in maths, in any questions, in any competitive exam, if you start with the equations that you can't solve, you check with options if you have options. Put the options. If it is satisfying, then it is the answer. No need to solve this one if it is problematic for you. So let's go for question number 6. What is there in question number 6? to find the rank. Again we have done rank yesterday. So if you see the matrix for rank, I have already told you to make it a canonical form. So here also you can see this is of this format, and similarly a square e to the power n. So what was the canonical format? This is one. Okay, done. Next, what I told you, to make it 0, then you will make it 0. I told you, remember, this way you will always proceed. You make this one 1, then this 0, this one 1, then this 0. This is always the procedure. So if you want to make this one 0, what I will make, R2 is replaced by R2 minus R1. Similarly for this one 0, again I will replace R3 by R3 minus R1. So if you do this one in a single step only, you will get everything 1 minus 1 0, a minus a square, everything is 0. So if it is everything is 0, so number of non-zero rows is 1, so rank is 1. So if there is a direct questions of rank, similar, just to calculate rank, I am going to skip from next year. Expressing a matrix A as a, suppose 2 1 5 4 8 13, it is, they are showing to express, but it is not MCQ, but you have to solve it on. They can do it, they can make it MCQ by any way, so you have to clear with the concepts. So solve, because it is very, I think it's on 96 or 97, in the year of 96 or 97, very old question. But you solve these old questions also, in descriptive type question also, MCQ can be easily formed. So one is upper triangular, suppose this is upper triangular, this is lower triangular. So what is upper triangular means? Upper triangular means you will, and they have given the elements in the upper triangular matrix, U is 1, and the diagonal elements. So the diagonal elements are this. So upper triangular matrix means only in the upper triangular. This, if this is the diagonal, this is the upper triangle, this is the lower triangle. So if it is upper triangular means in upper triangle only you will get values, in lower triangular it will be 0. And this one is, so these will be 0. Okay, that much they have given. So let's proceed. It is a simple product. We know matrix product is row multiplied by column. So if you multiply this row, these and these, so if it is x into 1 plus 0 into 0 plus 0 into 0. So how much it is x? The x should be equal to 2. So that means this should be equal to 2. So this one we got. This was a missing number. Next, this row will be multiplied with this column. So 2 into x, 2x plus 0 plus 0. So what is that? 2x. 2x equal to 1. So x should be equal to half. Done. This is also missing. So now go for the next one. 2 into something that we don't know. Then 0 into something. Then 0 into something. So 2 into x, suppose 2x. 0 into something 0. 0 into something 0. So again 2x equal to 5. So x will be equal to 5 by 2. So for next one will be this multiplied by this. So if this one I double, suppose I don't know, this is x, this is y. X into 1x, y into 0 0 0. So it is x equal to 4. So this one will be equal to 4. So now again this one. So similarly you can go 4 into half is 2, then it is x, then it is 0. So it is 2 plus x, which is 8. So x is equal to 6. So similarly this one. So for next one, this into 1, x 0 0. So this is should be 6. So next for this one again 6 into this into this. So 6 into half 2, then it is x, then it is 0. 6 into half 3. So 3 plus x. 3 plus x equal to 27. So x should be equal to, so x should be equal to 4. Done. Next this one. So again this one will be 6 into 5 by 2, that is, okay, we missed a part, that is here 4 into for this one. So you 4 into the last one should be you check with this one, 4 into 1 4, then 6, so it is 4, then it is 4 into half 2, then 6 8, then the last one 4 into 5 by 2, that is 10. Then it should be 13, na? So for that 13, 4 into 5 by 2, it is 10, 6x plus 0. So it should be half, 10 and 6 and half 3. So for 6 into half 3, so 10 plus 3 13. Now you check for this one. So this into this, 15 plus 12, 27. Then how much more needed? 4. So that's why it is 4. Now you got it. So this is simple product, nothing else. So up to this much, that's all for today. We'll